Alright, this is my AP Physics Rube Goldberg project for Mr. Wilkins. I had already recorded this, but I had to change a few things because they weren't working out. So I'll point out what I changed when I get to it. But, so I tried a couple of times. If you look, it looks like a couple of times, right? So each of these marks was an attempt, except for I missed the target maybe 8 times out of all these. So if you want to count them up, go ahead. I'm not feeling it. I lost count. I don't feel like counting it. So the Rube Goldberg starts with me back here, and I throw a kunai. And I throw the kunai at the target, and it sticks. And the kunai has a velocity. The target has a velocity of 0. The target has a mass, and the kunai has a mass as well. So it's basically like an inelastic collision, or a bolt in the block pendulum, because it's suspended much like a pendulum. So you could figure out the physics behind it if you wished. I'm not feeling it. I'm on break. So the kinetic energy from the kunai I throw is imposed onto the target, and that target then has the skewer, which is holding this back, this ball, at the top of a hill. So when I hit the target, the kinetic energy is transferred into it, pushing it down the hill, and the gravitational potential energy, since it's a sloped ramp, also is transferred into kinetic energy. Until at the end of the ramp, the ball runs into dominoes, and then each domino imposes its kinetic energy of falling to the domino in front of it. So it's just a long line of dominoes, which have already been triggered. And then at the end of the line of dominoes, there is a golf ball. Now this golf ball is sitting in a higher resting place than its target, and the last domino in the line pushes the golf ball off the table, and it hits the space bar. And the kinetic energy from the dominoes is transferred into the golf ball, and the golf ball has that kinetic energy as well as the energy that it feels when its gravitational potential energy transfers into kinetic energy. And then that kinetic energy then goes into pushing the spacebar, and that spacebar releases the electric energy stored inside of the computer, and that energy travels through this wire to the amp and to the speaker, and then the amp just steps up the energy in it, making it louder. And the speaker, the way a speaker works is it takes electric energy and it converts it into kinetic energy, because that's the way the speaker makes the sound. Is the membrane on the inside, it oscillates really fast, and it creates vibrations in the sound waves we hear. So the electric energy from the computer is transferred into the speaker, and the speaker then imposes its kinetic energy onto the foam balls, and the foam balls are pushed out of the speaker into the ramp, where once again the foam ball will change that kinetic, or the potential gravity energy, into kinetic energy as it rolls down the ramp. And at the end of the ramp there is a ping pong ball, which the foam balls will then push down its ramp, which kind of looks like an optical illusion. It looks like it's traveling uphill, but because of the way the ramp is made, it's not, because it can't roll uphill. That would break physics, and you don't want that. So the potential gravitational energy is transferred into kinetic energy as it moves down the ramp. And then at the end of the ramp, the ping pong ball will push this copper wire into the other end of the copper wire here, closing a circuit. And this is the part where I change. So before I always had the circuit closing, and I had this laser, which is a burning laser. So I could hold this match here for a few seconds if I try to line it up, and it would light the match because it burns. I had a whoosh bottle here, which I might show you what that is. Maybe I'll cut here. That whoosh bottle burned a hole in this. The whoosh bottle was lit by this laser. It lit a match on top of it, igniting the whoosh bottle, and the whoosh bottle then shot a jet of fire up, burning this thread. So here we have the kinetic energy of the ping pong ball closing the circuit, releasing the chemical energy stored in this battery, and the chemical energy is turned into electric energy. The electricity is then transferred into this laser diode, which changes electricity to light, and that light becomes focused at a point right about here, and it burns a little bit. So that the light energy is transferred into heat, and that heat energy is transferred into this thread, and it cuts this thread. It breaks it into two, and this thread is attached to a pulley, which when this thread is cut, the gravitational potential energy stored in this baseball pendulum is released, and this baseball swings down, and this looks like a peg pendulum, kind of, right? So it swings, and then it runs into this leg, this second leg here, that's hanging from the first leg, swings into this, and it hits here, and it wraps around, and it hits from this side. It hits this piece of PVC, which is basically a big lever. So the gravitational energy is transferred into kinetic energy, and then the kinetic energy of the baseball is then imposed into this, which is then imposed by a string into the throttle stick of this transmitter. And this transmitter takes the kinetic energy of the stick movement, and it turns it into an electronic signal, which it then transmits to my quadcopter, which is tied down so it doesn't move. It's like if you put a fan on a sailboat, so it pushes down on this board, it's not going anywhere. The electronic energy from the transmitter is received by this, and it translates it into a code which tells the quadcopter to release the chemical energy stored in the battery and transform it into kinetic energy of rotating the props. And the kinetic energy of rotating the props then pushes air down at a very fast rate. And it pushes the air down and around it and onto everything around it. So the air is pushed underneath these pages, and the pages of the textbook will then flip. And I would say something about how hopefully it works, but at this point I already know it works, and I already know it was a big pain, so I hope you enjoy it. Please enjoy it. Also, if you want to count, go ahead, but I'm not going to. Alright, I'll see you at the start of this big project.